Hello everyone. Welcome to this session of blockchain interview questions. My name is Saurabh and I'm part of the Simplilearn team. So let's get started and understand what kind of interview questions can come for a blockchain interview. So let's start with certain beginner level questions. Now, when you face a blockchain interview, you can get different variety of questions. So we will be covering that what kind of questions can be asked at each level, beginner, intermediate and expert level. So one of the few questions which you could be asked is, what is the difference between blockchain and hyperledger? Blockchain is basically the underlying concept. Blockchain is a decentralized technology of immutable records called blocks, which are secured using cryptography. Whereas Hyperledger is a platform or an organization that allows people to build private blockchain. So basically, blockchain is a concept, is a technology. Using blockchain, you can build public and private blockchains, but Hyperledger is a specific technology which allows you to build only private blockchains. Now, blockchain is divided into public, private, and consortium blockchains. Hyperledger is specifically a private blockchain technology where the access to blockchain data is limited to predefined users and it is defined using certain configurations and programming. Blockchain can be used in multiple fields like business, governments, healthcare, other different kind of domains, and etc. Hyperledger is primarily used in blockchain for enterprise-based solutions. So wherever we are talking about public blockchain, it is like usage of blockchain on internet, and hyperledger-based blockchain solutions are solutions which are meant for intranet within an organization, within a corporation. Second, how do you explain blockchain technology to someone who doesn't know it? So basically, in simple terms, blockchain technology is a distributed ledger which stores transaction details in the form of immutable records, non-modifiable records, which are called blocks, which are secured using cryptography. So in order to explain simplistically, let's consider an example of a school where blockchain is similar to a digital report card of a student. Now each block contains students' records which has a label stating the date and time of when the record was entered or when the record was registered on the blockchain. Now neither the teacher nor the student can modify the details of that block, cannot modify the record of report cards. Therefore, the record becomes non-modifiable, immutable. Also, the teacher owns a private key that allows him or her to make new records, and the student owns a public key to view and access the report card at any time. So basically, the teacher owns the right to update the record, but the student only owns the right to view the record. Now this method makes the data both accessible and secure, and this is what blockchain brings on the table. These are the primary attributes for which blockchain is getting widely adopted, to have immutable records available for view to the public and available for updating in an untamperable way. Now, what is a Merkel tree? Merkel tree is a data structure which is used for verifying a block. It is in a form of a binary tree containing cryptographic hashes of each block. So basically, a Merkel tree is structured similar to a binary tree. Each leaf node is a hash of a block of transactional data. So each leaf node is basically a transaction which is hashed, and each non-leaf node is a hash of its leaf node. So basically, hash AA is the hash of two blocks, hash A and hash B. Merkel root or the hash root is the final hash of all the transaction hashes. So basically, Merkel root is the hash of hash AA and hash BB. So it encompasses all the transactions which are underlying all the non-leaf nodes. What do you mean by blocks in the blockchain technology? What is the definition of a block? So blockchain is a distributed database of immutable records called blocks, which are secured using cryptography. Now, as you see, there are the certain attributes of a block which are displayed here. You have previous hash, transaction details, nonce, and a target hash value. So a block is like a record of transactions. Each time a block is verified, it gets recorded in chronological order on the main blockchain. So as you can see, as it is represented over here, every time a new block is verified, it gets added to the main blockchain with all those attributes populated. Now, once the data is recorded, it cannot be modified, it cannot be changed. Now, another question which would come into your interview is, how is blockchain distributed ledger different from a traditional ledger? It is a very important question. We need to know the basic difference and justification if we have to move from a traditional database to a blockchain based distributed ledger. What benefit it brings on the table. So certain differences which are very visible are transparency. Blockchain distributed ledger is highly transparent as compared to traditional database. Distributed ledgers are irreversible. Once any information is registered on a distributed ledger, cannot be modified, whereas on a traditional ledger it is reversible basically. Distributed ledger is more secure. It uses cryptography. Every transaction is hashed and recorded. In a traditional ledger, the security can be compromised. In a distributed ledger, there is no central authority. It's a distributed system. The participants of the network holds the authority to maintain the sanity of the network and are responsible for validating the transactions. Whereas traditional ledgers are based on the concept of centralized authority and control, and all the transactions are controlled by the centralized authority. In a distributed ledger, identities are unknown and are hidden, whereas in a traditional ledger, identities of all the participants have to be known before the transaction can happen. In a distributed ledger, there is not a single point of failure. As the data is distributed, information is shared across multiple nodes. Even if a single node fails, the other nodes carry the same copy of the information. Whereas in a traditional ledger, in a centralized database ledger-based system, that particular system becomes a single point of failure. If the single system crashes, the entire application or the entire network comes to a standstill. Ability to modify data? No. Once the data or a transaction is registered, it cannot be altered. In a traditional ledger, it is possible. How validation is done? So in a distributed ledger, it is done by the participants of the network. In a traditional ledger, it is controlled by the centralized authority. Copy of ledger is shared amongst all the participants of a distributed ledger. Each participant consists the same information in the ledger. In a traditional ledger, only a single copy is maintained at a centralized location. It is not shared amongst all the participants. Thereby, again, it remains as a single point of failure. If you have any queries, you can put your comments in the comment section of this video and we will definitely come back to you. How can you identify a block? What are the attributes of a block in order to understand it? So every block consists of 4 fields. It holds the hash value of the previous block. Therefore, it gets linked in a blockchain. It contains the details of the aggregated transactions which are aggregated in the block. It has a value called nonce. Nonce is a random value which is used to vary the value of the hash in order to generate the hash value less than the target. And then finally, you have a hash of the block itself. It is the digital signature of this block, a unique hash for this block. It is an alphanumeric value which is used to identify a block. So that is the identity of the block. The hash address is the unique identification of a block. It is a hex value of 64 characters that has both letters and digits. It is obtained by using SHA-256 algorithm. Now this is the way it is structured. The hash of the previous block, the transaction data and the nonce consolidate the header of the block. They all together are passed through a hashing function and then the hash value, the digital signature of the block is then generated. What is cryptography and what is its role in blockchain? Blockchain uses cryptography primarily to secure users' identities and ensure the transactions are done safely with a hash function. So all the user identities and the transaction on a blockchain are encrypted. Cryptography uses public and private keys to encrypt and decrypt data. So basically it uses the public and private key infrastructure in order to maintain the encryption of the information on a blockchain network. In blockchain network, public key can be shared with all the Bitcoin users, all the blockchain users. So public key is just like your address, which you can share it with anyone. But a private key is like your password. It is kept secret with the user. So basically, blockchain uses cryptography to secure user identities and ensure transactions are done safely. And how does it do it? It uses SHA-256 algorithm, which is secure, which provides a unique hash output for every input, and it is a very popular algorithm. The basic feature of SHA-256 is that whatever input you pass, it will give you a standard output, alphanumeric output of 64 characters. So basically it is a one-way function. You can derive an encrypted value from the input, but you can't do vice versa. Now, what are the different types of blockchains which exist? There are three different types of blockchains: public blockchain, private blockchain, and consortium blockchain. Public blockchain, ledgers are visible to all the users on the internet, and any user can verify and add a block of transactions to the blockchain. Basically, it's publicly available. Anyone can participate in the network and get hooked up. So examples are Bitcoin and Ethereum. Private blockchain ledgers are visible to all the users on the internet, but only specific users in the organization can verify and add transactions. So it's a kind of a permissioned blockchain, though the information can be available publicly, but the controllers and the validators of the blockchain are within the organizations and are predetermined. The example is Blockstack, consortium blockchain. Here, the consensus process is controlled by only specific nodes. However, ledgers are visible to all the participants in the consortium blockchain. Example is Ripple. Now, what happens when you try to deploy a file with multiple contracts? In blockchain, deploying a file with multiple contracts is not possible. The compiler only deploys the last contract from the uploaded file, and the remaining contracts are neglected. And this is the way a smart contract is deployed on a blockchain network. Now, very interesting question. What is a Genesis block? It's a very important question and could be asked in an interview multiple times. So basically, Genesis block is the first block in the blockchain, which is also known as block 0. So as you can see, the sequence number of this block is 0. And in blockchain, it is the only block that does not refer to any previous block. So the hash value of the previous block will be all zeros because it is the first block. Also, it defines parameters of the blockchain such as level of difficulty, consensus mechanisms, etc. to mine the block. So basically, it defines the primary attributes of the blockchain which is going to get initiated from the Genesis block onwards. Now let's look at some of the questions which would come if you are at an intermediate level. Now, how is the hash of a block signature generated? In blockchain, to generate a digital signature, transaction details are passed through a one-way hashing function, for example, SHA-256. Then, the output value is passed through a signature algorithm like ECDSA with the user's private key. Then, the encrypted hash along with the other information such as the hashing algorithm is called as the digitally signed document and is called the digital signature. So this is the entire process of generating a digitally signed block. List down some of the extensively used cryptographic algorithms. These are the few popular algorithms which are extensively used. SHA-256, Bitcoin uses it. Ithash, Ethereum uses it. RSA is one of the other popular algorithm. Blowfish, DDES. So it's very important to memorize these algorithms, the names of these algorithms when asked, and SHA-256 and Ithash are used in two of the popular public blockchain networks. What is a smart contract, and list some of its application? So smart contracts are self-executing contracts. These are basically digital contracts which contains the terms and conditions of an agreement between two parties, between two peers. Now, some of the applications can be used in transportation where shipment of goods can be easily tracked using smart contracts. So as there's a movement of goods and it is exchanging hands between different parties, there could be need of a contract and a smart contract between the parties. It is also used in protecting copyrighted content like music or books or the literature which you have written. So smart contracts can protect the ownership rights. It can also be used in insurance. It can be used to identify false claims and prevent forgeries. Employment contract, smart contracts can be helpful to facilitate wage payments, and it can be used as a proof of employment. Now, another important question, what is Ethereum network and how many Ethereum networks are you familiar with? Ethereum is a blockchain-based distributed computing platform featuring smart contract functionality that enable users to create and deploy their decentralized applications called dApps. There are three types of network in Ethereum. live network, the mainnet. Then there are a couple of test networks like Ropsten, Coven, and Rinkeby. And then you can also create your own private network using Ethereum. Smart contracts are deployed on the main network. They are publicly available and can be used by others also. Test networks allows you to run your smart contracts on a test net, validate the gas which is being used. You can just use these test networks as the main net, deploy your contracts, verify your decentralized application, and then move on to the main net. Private networks are those which are not connected to the main network, which run within the premises of the organization but carry the features of an Ethereum network. Now, where do nodes run smart contract code? Nodes run smart contract codes on a Ethereum virtual machine. It is a virtual machine designed to operate as a runtime environment for Ethereum-based smart contracts. EVM is operated in a sandbox environment or isolated from the mainnet, and it is a perfect testing environment. So you can download the EVM, run your smart contract locally in an isolated manner, and once you have tested and verified it, then you can deploy it on the mainnet. Now, a very important and a very good question. What is a Dapp and how is it different from a normal application? We need to understand these differences very thoroughly in order to clear our interview. So a Dapp is a decentralized application which is deployed using smart contract. The information on a Dapp is distributed and shared. In a normal application, it has a centralized database which is running on a centralized server. So you have a single server and a single code which is maintaining the entire application. No information is shared and it is a single point of failure. A Dapp has its backend code, a smart contract which runs on a decentralized peer-to-peer network. In a normal application, it's a typical computer software application that is hosted on a central server. So if we see in the differences in the process, you have a front end, then in the middle, you have a smart contract which is acting as the backend code, and then the entire transaction executed on a smart contract is shared between the blockchain participants in a P2P network. Whereas in a normal application, the front end interacts with a centralized API which performs basic CRUD operations, create, read, update, delete on a centralized database, and it is a single copy of the information. Name some leading open source platforms for developing blockchain applications. So Ethereum is one of the popular platforms for building blockchain based applications, and it is widely getting adopted. Eris is also used for building enterprise based solutions, and also some of the widely used platforms for building blockchain are listed below. Hyperledger, multi-chain, open chain are available in the market. What is the very first thing you must specify in a Solidity file? Now it is necessary to specify the version number of Solidity at the beginning of a code, as it eliminates incompatibility errors which can arise while compiling with another version. It is a mandatory clause which has to be there at the top of any Solidity code which you write, and you need to mention the correct version number for which you have written the code. Now, what is the difference between Bitcoin and Ethereum? And it's a very important question which I also ask in a lot of interviews, and it's important for you to remember these differences. So Bitcoin, the concept is purely P2P currency based transaction, but in Ethereum, you can do both P2P currency transaction plus you can deploy smart contracts. Bitcoin is primarily working on proof of work consensus mechanism. Ethereum is shifting from proof of work to proof of stake. Bitcoin uses SHA-256 hashing algorithm, whereas Ethereum uses ithash. Time taken to mine a block currently on Bitcoin is approximately 10 minutes, whereas in Ethereum it gets processed in 12 to 15 seconds. The reward for mining on Bitcoin as of today is 12.5 Bitcoin, whereas in Ethereum it is 3 Ethers plus the transaction fees. On Bitcoin, the transaction fees are optional, whereas in Ethereum the fees is calculated based on the gas which is being consumed on a smart contract per transaction. Value of Bitcoin as of 21st August was captured at $6,934 whereas Ethereum stands at $278. Now, what is nonce and how is it used in mining? In blockchain, mining is a process to validate transactions by solving a difficult mathematical puzzle called proof of work. Now, proof of work is the process to determine a number, a nonce, that is the number, along with a cryptographic hash algorithm to produce a hash value which is lower than a predefined target. Nonce is a random value which is used to vary the hash value so that the final hash value meets the hashing condition. So the nonce is the value which is being generated by the miner in order to guess the hash value, which should be less than the target value. And then only the miner can claim the reward for if he's mining a Bitcoin network of 12.5 BTC and a Ethereum network of 3 ethers. Now let's look at some of the advanced level questions. Name the steps that are involved in a blockchain project implementation. So in a typical blockchain-based project implementation, we start off with requirement identification. We need to understand the problem and goal. We need to identify the suitable consensus mechanism. What is the most suitable platform which can solve the problem? And then identify the implementation and deployment costs. We need to give an ROI to the client. Then we move on to the planning stage. In this step, an individual evaluates all the requirements, lists them down, prioritize them, and decides a suitable blockchain platform which has to be used to implement this particular problem. Then kicks off the development and implementation of the project. You design the architecture, you design the user interfaces, and start building the APIs. And then comes controlling and monitoring the project. You apply the proof of concept, you start off with that, and then start building the application on top of it. And then once the basic version of the application is available, you start identifying bugs and start fixing them. Explain a real life use case where blockchain is being used. So supply chain is the biggest adopter of blockchain, and as you can see, as the raw material moves is exchanged between different entities in a supply chain, the traceability of that particular digital asset, which in this case is raw material, is a big case study on blockchain. In supply chain management, smart contracts provide permanent transparency, traceability, and validation of transactions shared by multiple supply chain partners. So at each level, each supply chain partner has to register a transaction when it receives a product and then when it passes it on. So basically, the purchaser, when consuming the end product, can see the entire journey of the product. List and explain the parts of EVM memory. So the memory of an EVM is divided into 3 parts: storage, memory, and stack. Storage values are stored permanently on the blockchain network, and it is extremely expensive. So whenever you will try to modify a storage-based variable, you would have to pay gas for it. Memory variables are temporary modifiable storage area. It can be accessed only during the contract execution, and once the execution is finished, the data is wiped off, vanished, and it's lost. Stack, on the other way, is a temporary and a non-modifiable storage. Here, when the execution is completed, the content is lost. So basically, memory and stack are relatively much cheaper than storage variables. Now, what happens if the execution of a smart contract costs more than the specified gas? Initially, your transaction will be executed, but if the execution of a smart contract costs more than the specified gas, then the miners will stop validating your contract. The blockchain will record the transaction as failed, as highlighted, and also the user does not get a refund. So it becomes of utmost importance that when you are deploying your smart contract, you do the calculation of the gas consumption in the most correct fashion. What does the gas usage in a transaction depend on, and how is transaction fee calculated? So gas usage depends upon the amount of storage you are using. If you're using storage-based variables, then the cost of the transactions will be high, the gas will be high. And the set of instruction codes used in a smart contract. Basically, what operations you are performing on the storage-based variables, either they're costly. And if you are using huge amount of storage variables, then automatically the cost of your smart contract will keep on increasing. So basically, the transaction fee is calculated in ethers, which is given as the gas price which you have determined for your smart contract and multiplied by the gas limit. And this is how your transaction fee is evaluated. Now, what is fork and what are some of the types of forking? So in simple terms, updating a cryptocurrency protocol or code is called forking. Fork implies that a blockchain splits into 2 branches, and forking is done when you want to modify certain attributes of an existing blockchain network. It can happen when the participants of the network cannot come to an agreement with regards to either the consensus algorithm or they want new rules for validation. So there are 3 types of forking: hard forking, soft forking, and accidental forks. What is the difference between proof of work versus proof of stake? And it's a very important question. In blockchain, proof of work is the process of solving a complex mathematical puzzle called mining. Whereas proof of stake is an alternative proof of work by which the blockchain aims to achieve distributed consensus. In proof of work, probability of mining a block is based upon the amount of computational work done by a miner. Basically, it consumes huge amount of resources, electricity, resources and computational resources of the miner. Whereas in proof of stake, the probability of validating the block relies upon the amount of token you own beforehand. So the more the tokens you have, the more the chance you get to validate a block. So basically, proof of stake has been introduced in order to reduce the pressure on the resources which has been put by the proof of work consensus algorithm. Miners spend a lot of computing power for solving the cryptographic puzzle along with the hardware, and it's a huge cost. So basically, proof of stake was created as a solution to minimize the use of expensive resources spent in mining. What is a 51% attack? In blockchain, 51% attack refers to a vulnerability where an individual or group of people can control the majority of the mining power or hash rate. So basically, they can take over the 50% of the blockchain network. This would allow the attackers to prevent new transactions from being confirmed. Further, they can double spend the coins. Now, in 51% attack, smaller cryptocurrencies are primarily being attacked, which does not have a huge network, which has a small consumer base. What are function modifiers in Solidity, and mention the most widely used modifiers. In Solidity, function modifiers are used to easily modify behavior of your smart contract. It can be associated with a function, and then whenever a function is called, the modifier is called before the main function. In simple terms, it can build additional features or apply restrictions on the function of smart contracts. The most extensively used function modifiers in Solidity are view. View functions are functions that cannot modify the state of a smart contract. They are only read-only functions. Here is an example. You have a function get Simplilearn name, and it is having a modifier view which only returns a value, but you are allowed to use some inbuilt Solidity functions like msg.sender. But in case of pure functions are functions that neither read nor write the state of smart contracts. They return the same result determined by its input variables. So basically, you can't even access the inbuilt functions of Solidity. So here you have a function called calculate. You can only use the input variables. You cannot use any of the inbuilt functions also of Solidity. Now let's take a look of an example in order to write a crowd sales smart contract code in Solidity programming language. So here in the example, you have a smart contract where you have defined certain smart contract variables of Solidity like address and uint. Now the address function is if you want to send your token to someone, and your uint is the funding goal in ethers, basically how much amount of ethers you want to generate in your crowd sale project. Then what is the duration of your project, then cost of each token in ethers, then address of token used as reward. So these are the primary attributes which you have defined. Then you have your public functions which are defined over here. The beneficiary if successfully sent to, the funding goal, the deadline of your crowd sale, and the price. Now here is your default function which is defined in a Solidity contract which does not have any function name and is called by default in your smart contract if anyone invokes a method in your smart contract which does not exist. In this function, you are making sure that all the amount which has been passed to the smart contract is passed to your address. Basically, you are the originator of your crowd sale function, crowd sale smart contract. So you should be receiving the amount. Then in your crowd sale smart contract, you can have a method which is called as safe withdrawal, and you have appended it with a modifier called after deadline. So which basically checks that you can only do a withdrawal after the deadline has been achieved. And in this function, you are checking the balance, then you are withdrawing that amount from the sender and transferring it to your own account as the sender has sent that amount to you. So you do the basic validations whether the sender has that balance, and then you do that transfer to your account. I hope you all had a great session, and I'll meet you in my next session. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.